right, hello and got my mic a little low. All right, hello and welcome to another episode of Space Audits. Today we're gonna audit some space or whatever. Just kidding. I wanted to do a kind of I wanted to do a sharing of information video, so to speak. So Fractal Woman, whose channel I've been following for a long time, she puts out amazing work. Has done a lot of research into magnetism, interferometry, all kinds of aspects of things, vortexes, the ether, etc. She has a really nice breakdown on this paper by Anal Denou in Maxwell's equation. You could learn a lot here from this. She is a really powerful resource for free thought and independent ideas, and like examining research, breaking it down, and she'll even show you hey, this is where I differ from mainstream opinion, blah blah blah. My internet's not behaving appropriately. So anyway, I was gonna load the video thing and showcase, but I guess it's not gonna let me. So that's a shame. So anyway, this video was awesome. Did a very 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 informational. And it's what I like about it is you show the way that you logically work out how your worldview of it, or how you interpret it rather. And that's awesome, man. I love that. So it was a blast to watch this. And at the end, you mentioned some stuff about relativity and the assumptions about the ether and the Earth's motion and all that stuff. And I wanted to kind of present my alternative view to you, showing my research and, expanding on the ideas of, expanding on the interferometry experiments with, or as they went down. So like Michelson-Morley, Sagnac, Michelson-Gale-Pearson, and others. So we're going to, without further ado, I'd like to run you down the history that I've found and kind of give you the quick little TLDRs on the experiments, and then I'll link you the papers and you could check them out for yourself. So we'll go from there, and then I'll kind of explain some things as I go along, just for audience sake, so we can get some content out of it for everyone. All right, so starting off with the ether wind. So I took some notes, a couple of notes on your video that I'll bring up here, that I wanted to just kind of show, just to say hey, have you heard of this? This isn't you're debunked or anything like that, or like one of those kind of videos. Again, this is just sharing of information. You've shared opened up the wrong thing here. You've shared a ton of information with me, and I've learned a lot from you. So, maybe I can reciprocate or whatever, So here we go. So starting with 1887, we got your Michelson-Morley here. Now, as you pointed out in the video correctly, this was a test of Earth's motion Earth's motion around the sun, and they were going to deduce that speed through the ether because the speed of light would be relative. The propagation would vary relative to that to the observer's velocity, right? Because everything would be relative to the ether. Because you know how they say, the absolute reference frame and all that, and people are what does that mean? Well, it's twofold. It's one, it's a mathematical concept, and then secondly, it's the physical mechanic for the ether, right? For ether physics, where everything would be relative to that, including electromagnetic propagation. And then to experimentally prove that, you would have to take measurements of something in motion, and then show a first order dependency on the variance in the speed of light that corresponds to that motion, right? And I'll show a lot of experiments moving forward that show that directly. So the importance of of the ether framework is that's the mechanism that it provides for motion. And then secondly, something else I wanted to say, but I kind of forgot, but we'll just roll with it, right? So just to kind of close out, this is just for audience sake, not you, Fractal Woman. So this is just, in what precedes, only the orbital motion of Earth is considered in combination with the motion of the solar system. So like you're saying, how do you consider the different reference frames and whatnots? So they're saying they didn't seem to measure any insane velocities, and the only thing that they measured was a small shift. So they say it appears from what precedes reasonably certain that if there be any relative motion between the Earth and the luminiferous ether, it must be quite small. quite small enough to entirely refute Fresnel's explanation for aberration. And then also it goes on to say that Lorentz's theory would also be falsified because there was no velocity potential. Because again, if there was a velocity potential, there would be a first order dependence on the variance in the speed of light. So when they were making their fringe shift predictions, that's why they came up with 5 fringes, and each fringe was going to be 5 kilometers a second, because it was all predicated on that relationship with electromagnetic propagation varying to your relative motion to the ether, right? So, okay. Oops. Quit Thunderbird. Yeah. Cool. All right. And then, so of course, Sagnac came. Okay, yeah. So, and then that was the jumping off point for special relativity, as you stated. Some people like to deny that for some reason and act like it's not significant and whatnot. But yeah, so that was the mechanism for putting for the I'm sorry, that was the jumping off point for special relativity. So Einstein, proposes length contraction, time dilation of space, and all that. Without an ether mechanism to facilitate the variance in C, and then he actually says that the fringe that was produced was due to that length contraction and time dilation. And in fact, if you reverse that through the length contraction, the full 30 kilometers would be shown in the fringes, but blah blah blah, right? So that's the Einsteinian explanation for the Michelson-Morley experiment. And then also they say that Earth's motion is linear, right? So the important distinction here for the linear motion is that special relativity is a theory in regards to linear motion where there's no change in it really. Now the Earth's orbit is elliptical a little bit, so there is some variance in the speed, but for the most part, they say that the speed change is very slow and subtle, and not by very much. I think it slows down. There's like I forget the speed ratio or whatever, but it's like whatever, so they consider it linear in that regard. So the Michelson-Morley experiment, the way that they had the device set up, it was an orthogonal setup, and they had one of the arms set up in the direction of motion, and they had the other arm perpendicular to that, where it was going to catch the ether drag through a stationary ether, because their assumption was that that's how the ether worked, and Earth's motion was assumed, right? So in another model, you could say that the Earth is stationary, and that there's an ether wind that facilitates all the same mechanisms, and that's actually what I'm going to break down here, because like I said, so how they say you can't measure linear motion and all that stuff. So that's actually going to be shown to be false here when we get to the experiments in 2004, and some other interesting stuff. But so we'll just go ahead and continue on with the historicity here. So we got Sagnac with a rotating interferometer. So he used like a triangle set up on a rotating platform, and he got a displacement that corresponded to the motion, or that corresponded to the rotation of the device. Now they say that because this is a non-inertial frame, the variance in the speed of light is okay, blah blah blah. But disregard all the relativistic explanations. This equation here derives the effect without any relativistic corrections. So when they get into special relativity, for a long time there was no special relativity answer for this, although they do try and give a couple for it, but it's inadequate. And then so it wasn't until 1921 where Paul Levoux came along in general relativity, and he made a special tensor to account for angular momentum on the small scale, and said that the rotation of the device through the equivalence principle is equivalent to generating pockets of time dilation and length contraction, right? So like the energy of it is equivalent to generating a gravitational field, which produces the effects of length contraction and time dilation. Is kind of the explanation that they went for, and that's like the mainstream TLDR quick broad overview of it. There's actually like 15 different explanations. The Sagnac effect was a huge discrepancy for them in special and general relativity, but we'll just move forward as if it's all good, just for the sake of moving forward. So they have in 1925, we have Michelson-Gale-Pearson, where they did a square and a rectangle configuration with 4 mirrors. Now, what they did here, this is stationary fixed to the Earth, right? So in Sagnac's work, he's rotating, right? So that they say that this motion is independent of Earth, blah blah blah, and all that, right? So the way that they take the way that they also explain it is that the Sagnac device is rotating relative to the fixed stars, right? So it's independent of Earth's rotation. So, but anyway, either way, it shows a first order dependence on the rotation to produce the effect. So what we have here is again Michelson-Gale-Pearson. So they say the observed in the cliff notes here on their paper. They say the observed displacement in the fringes was found within 0.23 plus or minus 0.05, agreeing with the computed value of 2.36 plus or minus 0.02 within the expected experimental error. Oops, I don't have the. Oh, sorry, it was down here. My bad. So this is calculated on the value with the assumption of a stationary ether as well as in accordance with relativity. So ignore the relativity part, doesn't matter. This equation right here is not a relativistic equation. This is what they're using to derive the change in speed relative to the latitude on a spinning globe. So if the Earth were stationary, and I'm not going to bring a flatter globe into this, but let's just say for the effects of a stationary globe, the ether wind would be rotating, an encompassing ether wind of the universe, right, would be rotating around it uniformly. So there would be like a motion gradient relative to the latitude. You could look at it that way, right? So that's the way that that's what they measured at their latitude. This is the equation that they used to derive it, and this is on the assumption of a stationary ether framework. And actually, real quick, let me see if I can pull this up. Second, because I'm just not sure what paper it was in, where I have how they did the one thing. Give me 1 second. History of interferometry. Oh, it's literally called interferometry presentation, perhaps. Okay, let's see. It's loading. Okay, yeah, here we go. Awesome. Okay, so Michelson-Gale-Pearson. Michelson-Gale. Right here. Okay, yeah. So where they're deriving it, this equation is not relativistic at all. This is a relative. So those pipes were the way that they had them orientated again was similarly to the Michelson-Morley, where there was an orientation north-south and east-west. So this equation here just breaks down a comparative motion or the comparative speed of light relative to the from the north-south poles relative to the east-west poles or pipes. Sorry. So yeah, no relativistic effects there, even though they make it a point to say it's in accordance with relativity, blah blah blah. Doesn't really matter. So the theory of the effect of the rotation of the Earth on the velocity of light is derived on the hypothesis of a fixed ether. So remember, the variance in the speed of light would be facilitated by motion, right? So if the ether is in motion and the Earth is stationary, and you measure, and you have something that's precise enough to measure or to like break down the fringe patterns and measure it on that level, you can show the variance in the speed in that regard relative to how far away it is from the ether vortex, right? So on the globe, imagine there's a ether vortex at the North Pole just going straight down, and then all encompassing from that is a rotating vortex, right? So what you would have is as you got further away from the center of that vortex on the globe, you're going to start to get a increase in the speed. So at the equator, it would be 1,000 miles an hour, right? Let's just say. And then if you got to like the 45th latitude, for example, you would get 750 miles per hour. So like that's the kind of relationship that you could equate it to. Now, is the light going to reflect that exact speed? In the sidereal, when you plot it against the sidereal time, it does actually. And so very, very cool. And so when we're when we're saying what's in motion, what motion is facilitating the variance to the speed of light? Is it the motion of the ether or is it the motion of the rotating globe, right? So like that's the distinction here. So on a stationary ether framework, it would be the rotation of the globe. Now on a uh, stationary globe, it would be a rotating ether, right? So there you go. Same difference. Sorry, this isn't just to like like dumb it down for you or whatever. Like I'm sure you get this first concept or whatever. This is just to repeat it, get it out there for the audience, and for my own sake to just get used to talking about it quickly and getting the points out and stuff, and just so building a way to articulate it. So I apologize if it's like, okay, we'll get to the point. I'm not retarded, or but so anyway. Okay, so Dayton Miller followed up the let's see here, in Michelson-Morley. They end up saying, hey, so to figure out if there's any way to measure the variance in the galactic speed of the galaxy or whatever and all that, the experiment should be followed up at different times of year and all that, right? And Michelson never followed up on it, but Morley joined my boy Dayton Miller over here in 1905, and from 1905 to like 1927, 1927, they conducted a ton of experiments. Morley wasn't in on all of them, but he did follow up on a bunch of them in the early 1900s with Miller. So he was his lab assistant. So anyway, Miller reproduced the Michelson-Morley apparatus. He actually also inherited the old apparatus and did a bunch of controlled experiments with that one, with one that he built in his own lab at Case School, or Case Physics School, or whatever it was called, and then he had the one that he built and took to Mount Wilson, and where he did his grand opus, really. So earlier when you were talking about, you mentioned something about burning the haystack, right? So when you're taking these measurements and you're really trying to isolate what's the exact variable that's causing this motion, right? How do we isolate the ether effects from all the noise of everything else, right? So from 1924 to like 1926, I think, or 25, Miller did the most extensive control, and throughout his whole career, he did a bunch of controlled stuff that he contributed to this. But between those 2 years in particular, he went hard and really hammered out all the variables that could affect the readings in interferometry. So this guy right here, James Demio, does an awesome review of Miller's work and the control variables and all that. So to give you a quick rundown, so like, radiant heat sources, the temperature differentials in the air, the materials that the apparatus is built out of, the shielding of the apparatus, or the shielding that he uses, to isolate the to make sure like the air is not blowing through and all that stuff. So he puts a shield around it, and then he has a material that he covers that shield with as well. Like all this stuff, and the materials that it's made out of contributes to how strong the fringe shift readings are, and also the location of the apparatus. So Michelson-Morley was done in a basement, at I forget where they did it. Where was it? Somewhere in Ohio or something, or whatever, Cleveland. But that was in a basement, concrete walls, all that stuff. So what Miller actually found is that when you take the device to altitude, like on a mountain or whatever, you can get crazy readings. So to show some quick stuff here, I think, because I'm going to show you his setup. So he came up with this canvas covered, just open area, not in a basement, not in a concrete basement, right? So, and then he also through the insulation and stuff that he used, he was able to control the temperature and all that, and really hone the variables and just get a nice ether reading fluctuation. And what he found, taking the readings at different times of the year of the equinoxes, so on the heliocentric model, when the Earth is going around the sun, has to slow down and speed up 4 times a year to complete that elliptical orbit. So he took these measurements during those times, and what he found was that the fringe shift patterns reach their minimum and maximum dimensions on the equinoxes to the day when the Earth when it's like, okay, we're at this equinox, this is the day of the equinox, and then all the days after are leading to the next one. On that last day, that's when they reach their minimum and maximum dimensions, when the Earth would be going its slowest or fastest, right? So to show a quick demonstration on a globe. Actually, it doesn't matter. So yeah, he plots when the data is plotted against sidereal time, it shows that relationship with the minimum and maximum dimensions on the equinoxes. When it's plotted against civil diurnal time, so i.e. like the seasonal effects, temperature differentials during those seasonal times, so like when it's hot, cold, etc., humid, the data shows no causation effect or whatever, right? So, and then of course you can get into Robert Shanklin, who did his assassination piece on Miller's work by selectively picking two data sets where the only two data sets where there was a diurnal seasonal relationship where it showed that. He took those two data sets, and then he took data sets from Miller's controlled studies, which were unpublished and not presented as any sort of evidence for anything. These were just his data from his controls. Shanklin took that and then used that to show what was actually going on. If you read Miller's work, he was forcing an actual null result by altering the apparatus. So when you alter the length of the apparatus, one of the arms, if they're disproportional, if you change the medium in which the light is or the electromagnetic propagation is happening in, you get varying effects. And if you change the location of the sensor, you get varying readings. So he had come up with a way to narrow it down to like almost zero. And Shanklin uses that to go, look, this is no fringe or whatever. And he uses that to like reify the correctness of relativity theory. But like in the way that he did that, now that you now know that as his selection of the data, you can see that it was obviously to hide this, to hide the correctness of Miller's work, which would invalidate special and general relativity. Now, so it should be noted here that Miller got a stronger reading than the Michelson-Morley experiments, but not that much stronger. So if the Michelson-Morley experiment was like just over one fringe to produce 6 to 7 kilometers, right? If one fringe was going to equal 5, Miller got 8 to 9 or something like that, or 7 to 10. Like there's different sources there to extrapolate how much he got, but so roughly it's like 7 to 10, or it'll be referred to like 8 to 10 or 8 to 11, something like that. Like there's variations in it, but anyway, slightly more than Michelson-Morley, right? But not enough for the full fringe. If the Earth were in motion relative to the ether at 30 kilometers a second, right? So a huge discrepancy there, and that's why they had to continually ignore Miller's work, because what he was consistently showing through ether physics is that there was no relative motion of the Earth, right? So now, though, obviously they were interpreting these mechanisms they were interpreting the slight fringe through the mechanism of contraction, because they really wanted that Earth's velocity to be true, but unfortunately they weren't able to get any first order dependency measurements on that. So far, they've only produced a first order dependency on an effect that they attribute explicitly to rotation through the Sagnac device and Michelson-Gale-Pearson. Okay. And then so when Miller plots out his data, he plots out the axis of rotation of the ether, which is really cool. So earlier, how I was saying in the heliocentric model, where the Earth has to change speed 4 times a year, and then so it's on its axial tilt, and on all of that, so to speak, the Earth is in the heliocentric model. So what he showed here is like in perfect tandem with what the heliocentric model would need if it were actually in in motion at 30 kilometers a second, if it had that first order dependency relationship. I mean, this guy would have been the Nobel Prize. He would have had all the prizes. Everyone would be like, who's Einstein? Like, Einstein's cool, but like Miller mapped out and proved the ether and all that. Like, it would be a totally different situation if they were to accept Miller's paradigm, but you have to accept second order corrections of length contraction and all that. And then when we get into the two types of interferometry, linear and circular, which one depends on linear motion and which one depends on angular rotation to produce a fringe, we're going to see why they absolutely cannot afford to say that the ether exists at all, because that proportional variance relationship with the observer's velocity right? So that isn't measured. So, okay. So I think that's all on Miller. So this is, let me show this. So yeah, this is his apparatus here. This is the apparatus with the shielding, and then he also had some paper stuff that he would put over these glass windows here that were protecting the light beams as they reflected over. And is there a topographical view of the light? No. So yeah, here it is. Okay, yeah, here we go. So there's a topographical view of everything. Pretty standard for. So and this is in regards to measuring linear motion, right? So for the Michelson-Morley, for Dayton Miller. Okay, and then so in 1942 we have Dufour and Pruner, and these guys really threw a wrench in things. So they won before they so in modern interferometry for the linear standards Michelson-Morley apparatuses, whoever, I don't know, the organizations who do these experiments that publish their results and whatnot, and have this thing where they say that the results that they're getting are trending to zero, which prove the correctness of Einstein's theories. Well, what they're actually doing when you read their experiments, they've actually altered their apparatus and conducted it in a basement and everything, and basically done all the factors that Miller figured out in his controlled experiments that would force a null reading. So they literally just do all that. So anyway, they don't actually they don't go, okay, this is what Michelson did. We'll recreate their apparatus. We'll maybe use some of the same parts if possible, but we'll do it analogous to what they did first, see if we can reproduce it, and then we'll build upon that, right? So almost none of these people do this. So what was really cool about Dufour and Pruner is that they were like, okay, we got to reproduce Sagnac's effect first in the way that it was first derived and all that. So the only thing that differed from their experiment was, I forget, there was one piece that they couldn't find from the original setup, but they ended up using the mirrors, and they doubled the area of the distance between the mirrors. So, but other than that, rotating device, same mirrors, and all that, right? So, and same wavelength of light as well. So they did their own setup and reproduced the Sagnac effect, and I'll just kind of read from the abstract here. So in a series of experiments here detailed, it is necessary to realize that we used an entire optical circuit attached to a revolving platform as the former work of Sagnac. Under these conditions, we noted that the displacement of fringes observed was in the same margin of 6%, whether the source of light of the photographic receiver are entrained as part of the rotation of the platform as these experiments of Sagnac, or as when they are fixed to the laboratory, which we'll get into further in the paper, which lead to some interesting setups. And they actually show that the location of the detector, like whatever takes that last reading, is what determines the frame. So very cool stuff. Because there's some speculation on whether if it was the last mirror before the reflector that determined the frame and all that, if it's inertial or non-inertial, but it's actually what determines the inertiality of the frame is the location of the detector. Very cool. So let's see, attached to the platform. So this displacement of the fringes obtained under these new conditions was used to predict the classical theory. So the classical theory being the relative motion shows a first order dependence or motion shows a first order dependence on the varying speed of light. In the discussion where the optical circuit is entirely attached to the revolving disk, as in the experiment of Sagnac, an observer has no means of making the choice in the interpretation of displacement of the fringes obtained by S, given respectively by the classical theory and by the relativist theory. But in the discussion where there is part of the circuit which remains fixed relative to the laboratory, the relativistic theory cannot remain in agreement with the classical theorist, nor with the results, assuming as he had done until here, that the center where he must assume the position to calculate the experiment can be chosen arbitrarily on a rotating platform. The center must be the center must be with the center of rotation of the platform. Sorry. So, quick recap on special relativity. The first postulate: all reference frames are equally valid. This is a pledge of allegiance to Lorentz symmetry, and what that means is that no reference frame is more equally valid than another. So when you do a transformation equation, the laws of physics will be invariant under those transformations. So every other things can change, but not that, right? So in relativity theory, the idea here is that on a rotating platform, you could derive the effect of relative motion without anywhere on the platform. It doesn't matter, right? So they're saying that they could derive the from anywhere on the platform. You could derive how much light would be displaced, from your rotation or whatever, right? And what they found was the relativity could only answer it from the center of the platform. Now they act like it's chosen arbitrarily for convenience, make the math simpler, yada yada. But Paul Levue couldn't do it. And this is the guy that invented the metric tensor for general relativity to ascribe the what's it called? The metric tensor to co-opt the Sagnac effect as a general relativistic effect with through the equivalence principle and all that, right? So yeah, this is huge because like he said, the location of the detector determines the frame, and although the rotation, so that means that there shouldn't be a displacement. The speed of light should be the same, because he is in an inertial frame. So when Paul Levue tries to calculate it, he can only derive the answer from the center of the platform, which on the relativistic side, assumes that because you can assume that's stationary, basically, is what they say, right? That's why it has to be the center, because that's the only point on the platform that you can actually assume it's stationary. Sorry to raise my voice. I just I was trying to get that out, but I couldn't get the words out. All right, so here's their setups. So the classic Sagnac, yada yada. Then they have the one where they put the observer on the wall, and here's a setup where they have a rotating platform, stationary observer, and then they have So get this. They have a rotating platform, and they have a stationary platform under it. When they do that experiment, and it's in the actually I'll have to reread that. I don't fully remember that off the top of my head because it kind of blows my mind. But basically what they showed was that there was a variance in the speed of light relative to, as if the rotating platform was translating its dependence of first order dependence of motion to change that speed of light for the stationary observer. Like, it's just mind blowing. Like that right there falsifies relativity on the face of it and proves that there's an ether. Because that's the translation of motion for electromagnetic propagation where there should be none. Okay. So anyway, so they have this split setup. So they would do have the detector on the wall. So they have another platform set up here, upside down, where they would have these 45-degree angled mirrors to accept this 45-degree angled mirror, and they would just bounce it off of this. So this one would be rotating, this would be stationary, and they would find that the effect is dependent on the rotation of this, even though this is stationary. It's absolutely insanity for relativity theory. Really cool stuff here. So that experiment isn't talked about. I haven't really heard anyone talk about it, but yeah, it's a crazy one. So Yuri Galev. So ethereal wind experience in millimetric radio wave propagation. So this guy, very cool, did radio millimeter wave propagation, and he reproduced Dayton Miller's work. So not only did he show like a Michelson-Morley variance in the speed of light or electromagnetic propagation, there's a variance to a degree that seems to follow the sun, right? So I know you're a heliocentrist or whatever, totally fine. Not the argue of contention, but we think that, or I'm coming from a perspective where everything is closer or more local, and the translation of motion is coming from that. And then obviously your perspective would be that the translation of motion is just coming from a much faster speed over a much greater distance. So, not much differences. And then obviously, the big distinction, flat earther for me, globe for you. But we don't, not the purpose of the discussion here, but I just wanted to point that, or, prep, just wanted to make it known so that, anyway. All right. So Ruyong Wang. So this is huge here. Because I think this is the reason I think that it's not the shape that we say it is, because if it's not a spinning globe around the sun in the way that they've claimed to experimentally measure through second order corrections through time dilation and length contraction to get their distance to confirm their model, I just don't believe that. And if that stuff isn't the case, then I think that we're on a plane. There's a vortex in the center. Blah blah blah. Right. So anyway. So the generalization of the Sagnac effect. So really awesome paper here. What this guy did is he unwound a fiber optic gyro cable, and he put it around the what's it called here? He basically made a conveyor belt out of it with little wheels, right? And then he showed here, and then he also has a setup where the motion of the conveyor belt will also pull this little tray here that has a fiber optic gyro on it as well, and to measure linear motion. So, and what he also finds here is that the linear motion in this track of the conveyor contributes to the full amount of the French shift pattern with a first order dependence on the motion, right, on the velocity, on v, right. So awesome stuff here. Let me show. Let's see here. So just to give a quick recap here. All right. Yeah. So the big thing that he found here is that the circular equation, the circular derivation for the Sagnac effect, right? Your delta t equals 4 times omega times a over c squared. So what they're saying there is just basically the fringe displacement is going to be equal to 4 times the angular rotation times the length that the total length that the light had to travel. So in a fiber optic cable where it's looped up, if you have a cable that's 1,000 meters long, your area is going to be 1,000 meters. If you have a little tiny, mirror reflecting apparatus, it's going to be the path that light has to travel, that total path, that total length. And then for the linear equation, same thing, delta t equals 2 times the velocity over the length, or times the length over c squared. So the key factor here is velocity just the motion, right? So, and then it's like, well, which type of motion? Well, he showed that these are equivalent and that they both derive the same, that you can actually derive the circular effect using the linear equation. They're completely equivalent. Okay, yeah, so that really takes away the Michelson, or with the relativistic paradigm where they say that linear motion of the Earth around the sun can't be measured, blah, blah, blah. It would absolutely be measured because there's a first order dependence on that V, on that omega, that produces that fringe. So if the Earth's orbital velocity existed, it would have reflected in the Michelson-Morley, in the Dayton Miller, like it would be there in Yuri Galev's experiment and in Hector Minera. Yeah. So also, in addition to the radiomillimetric propagation, Yuri Galev also did optical wave bands where you could see the fringe patterns, And he also, through doing this, he measured the viscosity of the ether. But I am not prepared to speak on all that. I'll have to reread this and really try and get my head around it. It's kind of above my pay grade for when they're measuring the kinematic viscosity of it. But maybe you can make sense of it. But anyway, that's what he did, and again reproduced Dayton Miller's work showing that fluctuation that corresponds to the equinoxes. So it's mapped to the sky, right? And then, so important thing to know here is, right, so on the globe, how they say that it's tilted at a 23-degree axis, right? If the globe isn't tilted in that regard, I'm sorry, that tilt matches the cosmic microwave background, right? The axis of rotation of the universe, the dipole of the cosmic microwave background intersects with Earth's supposed axial tilt, which is crazy. But another way to interpret that is that the universe is rotating around us, and this is what these people are measuring, right? So, let's see. So Hector Manera did. Okay, so what they did here is a dialpetometric, whatever this word is. What this word means is that they left the device running continuously. So instead of turning it on, taking the readings and all that, they just left it running for 3 years straight. And then over their culmination of data, they also reproduced Miller's work and showed that the fluctuations reached their minimum and maximum dimensions on the equinoxes. And their setup was extremely technical and precise using modern equipment and stuff. They didn't, they weren't messing around. So, yeah. All right. And then there's some really interesting analyses done by Robert Bennett and James Demio, like I was saying earlier. So Robert Bennett really breaks down the Sagnac experiment and the significance of that, and how it shows that the Earth is not in motion. So this guy is not doesn't believe the Earth is the same shape as me by any means, and he's a full academic guy, retired. But he, analyzed Wang's work and was like, "Holy crap, this is insane." So he writes an analyzation of everything, and breaks down how it shows that the Earth is stationary, and then also he has a breakdown of the Dufour and Pruner experiments. Now, the Dufour and Pruner experiments, and I'm familiar with this subject matter, and it's kind of like I'm on my second or third reading of the Dufour and Pruner, so. But this has been helpful in going over the Dufour and Pruner and breaking down that. So he has a summary of each experiment that they did. So when the rotor is at rest in the lab frame, the speed of light equals c in both reference frames. When the rotor moves at v in the lab frame, the speed of light equals c plus or minus v in both reference frames. Special relativity is disproven. Emission theory is disproven. Ether entrainment theory is disproven, and Galilean relativity is supported conditionally. And he goes into that by showing the covariant relationship for the Galilean law of adding velocity. So he shows that and how that effect is in alignment with dynamics. And dynamics is supposed to be covariant in all reference frames, and the only frame that's ever experimentally verified in dynamics is the lab frame, which is stationary. So this stationary frame, which is supposed to be covariant to all frames, actually produces non-invariant transformations of motion, which break the general principle or general relativity's principle of covariance, right? So because in the general theory, Einstein expanded the covariance principle to all reference frames, all mathematics, Galilean, et cetera, right? So, huge problem there for that. And he really hammers it home. And then, this is really cool. So Sagnac and de Pruner both found that the speed of light equals plus or minus v in the rotor frame. Dufour and Pruner found that the speed of light equals c plus or minus v. Also in the lab frame, the optical bench is at rest. An empty spinning platform below it. This alone disproves special relativity as the speed of light varies. Yeah. So very cool. Very cool. Yeah. All right. Well, I hope that, and I'll make all these papers available to you so you can check them out so you don't have to like dig them out yourself or whatever. Yeah, like let me know what you think. All right. You have a good night.